Welcome. Today we're diving into the world of network models, specifically the OSI and TCP IP models. These frameworks are essential for understanding how data moves across networks from your device to the internet and back. Whether you're a student, a professional, or just curious about how the internet works, this comparison will clarify the similarities and differences between these two foundational models. Let's start by exploring why network models are so important in the first place and how they help standardize communication across diverse devices and systems. The OSI model, or Open Systems Interconnection Model, is a conceptual framework developed by the International Organization for Standardization. It divides network communication into 7 distinct layers, each with its own specific function. The OSI model is widely used for teaching and troubleshooting network issues, as it provides a clear structure for understanding how data is processed and transmitted. By breaking down complex processes into manageable layers, the OSI model makes it easier to pinpoint where problems might occur in a network. The OSI model is structured into 7 layers: physical, data link, network, transport, session, presentation, and application. Each layer serves a unique purpose, from handling raw data transmission to managing user interfaces. This layered approach allows for modular troubleshooting and development, as each layer interacts only with the layers directly above and below it. Understanding these layers is crucial for anyone working with networks, as it helps clarify where specific protocols and technologies operate. The TCP IP model, also known as the Internet Protocol Suite, is the foundation of the modern Internet. Developed by the U.S. Department of Defense, it consists of 4 layers: link, internet, transport, and application. Unlike the OSI model, TCP IP was designed based on practical implementation and real-world protocols. It focuses on standardizing communication for the internet, making it the backbone of global connectivity. Let's look at how these 4 layers work together to enable seamless data transmission. The TCP IP model simplifies network communication into 4 layers: link, internet, transport, and application. Each layer is responsible for specific tasks, such as physical data transmission, routing, reliable delivery, and user-facing applications. This streamlined structure makes the TCP IP model more practical for real-world networking, especially for internet-based communication. Understanding these 4 layers helps clarify how data travels from your device to its destination across the web. Now let's compare the layers of the OSI and TCP IP models. While the OSI model has 7 layers, TCP IP has only 4. Some OSI layers are combined in the TCP IP model, reflecting a more practical approach. For example, the OSI's application, presentation, and session layers are merged into the application layer in TCP IP. Similarly, the physical and data link layers in OSI are combined into the link layer in TCP IP. This comparison highlights the conceptual versus practical design philosophies of each model. The OSI model's physical and data link layers are responsible for the actual transmission of raw data over physical media and managing error detection and correction. In the TCP IP model, these functions are combined into the link layer. This consolidation reflects the TCP IP model's focus on practical implementation, where hardware and data link responsibilities are often handled together. Understanding this difference helps clarify how each model approaches the basics of data transmission. The OSI model's network layer and the TCP IP model's internet layer both handle routing and addressing of data packets. Their main function is to ensure that data reaches the correct destination across interconnected networks. Protocols like IP Internet Protocol operate at this layer in both models. While the terminology differs, the core responsibilities remain largely the same, focusing on logical addressing and routing. Both the OSI and TCP IP models include a transport layer, which is responsible for end-to-end communication, error recovery, and flow control. Protocols like TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, operate here, ensuring reliable or fast data delivery as needed. This layer is crucial for maintaining data integrity and managing how data is segmented and reassembled during transmission. In the OSI model, the application, presentation, and session layers are separate, each handling different aspects of user interaction, data formatting, and session management. In contrast, the TCP IP model combines all these functions into a single application layer. This simplification makes the TCP IP model more streamlined for real-world use, but the OSI model provides more detailed conceptual separation for learning and troubleshooting. The OSI model's main advantage is its detailed, layered approach, which makes it excellent for teaching, troubleshooting, and understanding network communication. Each layer is clearly defined, allowing for modular development and easier identification of network issues. The OSI model also provides a universal language for discussing network functions, making it easier for professionals to collaborate and solve problems. Despite its strengths, the OSI model is often criticized for being too theoretical and not always reflecting real-world networking practices. Some of its layers, like presentation and session, are rarely implemented as separate entities in modern networks. This can make the OSI model less practical for direct implementation, even though it's invaluable for conceptual understanding. The TCP IP model's biggest advantage is its practicality. It's the foundation of the internet and is widely used in real-world networking. Its streamlined structure makes it easier to implement and adapt to new technologies. The TCP IP model is also flexible, allowing for the integration of new protocols and technologies as networking evolves. However, the TCP IP model is not without its drawbacks. Its layers are less clearly defined than those in the OSI model, which can make troubleshooting more challenging. The model also doesn't separate presentation and session functions, potentially leading to less modularity in some implementations. Despite these issues, its real-world effectiveness has made it the standard for internet communication. To better understand the OSI model, let's look at some protocol examples for each layer. For instance, Ethernet operates at the data link layer, IP at the network layer, TCP at the transport layer, and HTTP at the application layer. These examples show how different protocols fit into the OSI structure, helping you visualize where each technology operates within a network. Similarly, the TCP IP model includes protocols like Ethernet at the link layer, IP at the internet layer, TCP and UDP at the transport layer, and HTTP, FTP, and SMTP at the application layer. These protocols are the backbone of internet communication, and understanding where they fit in the TCP IP model helps clarify how data moves across the web. The OSI model is primarily used for educational purposes, network troubleshooting, and as a reference for protocol development. Its detailed structure makes it ideal for diagnosing network issues and understanding where problems occur. Many certification exams and textbooks use the OSI model as a teaching tool, making it a foundational concept for network professionals. The TCP IP model is used in real-world networking, forming the basis of the internet and most modern networks. It's essential for configuring routers, switches, and other network devices. Network engineers and administrators rely on the TCP IP model for designing, implementing, and maintaining networks, making it a practical tool for everyday operations. You might wonder why both the OSI and TCP IP models exist. The OSI model provides a comprehensive theoretical framework for understanding network communication, while the TCP IP model offers a practical, real-world implementation. Together, they complement each other, with the OSI model serving as a guide for learning and the TCP IP model powering the internet. In summary, the OSI and TCP IP models are both essential for understanding and working with networks. The OSI model offers a detailed, layered approach ideal for education and troubleshooting, while the TCP IP model provides a streamlined, practical framework for real-world networking. Knowing both models gives you a comprehensive understanding of how data moves across networks and the internet. Understanding the OSI and TCP IP models is crucial for anyone interested in networking. While the OSI model provides a solid foundation for learning, the TCP IP model is the backbone of the internet. Mastering both will help you troubleshoot, design, and implement networks more effectively. Thanks for joining this comparison. Keep exploring, and you'll gain even deeper insights into the fascinating world of networking.